sin theta by 1 plus cos theta plus sin theta is equal to x. So, theta by 1 plus cos theta plus sin theta equal to x. Prove that not prove that. If 2 sin theta by 1 plus cos theta plus sin theta is equal to x, find the value of one minus cos theta plus sin theta by 1 plus sin theta. Now let us take x equal to 2 sin theta by 1 plus cos theta plus sin theta, and let us multiply this by 1 plus sin theta minus cos theta by 1 plus sin theta minus cos theta, both in the numerator and denominator, because we are asked to calculate 1 minus cos plus sin. Now, the numerator is as it is. It is 2 sin theta into 1 minus cos theta plus sin theta. Denominator is, if 1 plus sin is taken as a, this is a minus b, and 1 plus sin plus cos, a plus b. Therefore, it is 1 plus sin theta whole square minus cos square theta. A plus b into a minus b square minus b square. Now, the numerator is 2 sin theta into 1 minus cos theta plus sin theta by denominator. Let us expand this 1 plus sin square theta plus 2 sin theta minus cos square theta. Now this 1 minus cos square is sin square, and this is also sin square. It is 2 sin square theta. So 2 sin theta into 1 minus cos theta plus sin theta by 1 minus cos square is 2 sin square theta plus this is 2 sin theta. Now 2 sin theta into 1 minus cos theta plus sin theta, by the denominator 2 sin theta is taken as common, and we are left with sin theta plus 1. These two gets cancelled. So the remaining thing is 1 minus cos theta plus sin theta by 1 plus sin theta. This is what we are asked to calculate. So therefore this is also equal to x. So this is given, and because 1 minus cos plus sin is asked, we have multiplied by 1 plus sin minus cos in the numerator and denominator. Therefore, this is 2 sin theta into 1 plus sin theta minus cos theta. And in the denominator, when we have multiplied 1 plus sin theta whole square minus cos square. Now, after expansion, this is 1 plus sin square plus 2 sin minus cos square. Numerator is as it is. Sin square, this is 1 minus cos square is sin square, plus sin square is 2 sin square theta, plus 2 sin theta. Now, the numerator is 2 sin theta into 1 minus cos theta plus sin theta. Denominator, we have taken 2 sin theta as common and left with sin theta plus 1. Now 2 sin theta gets cancelled, and the remaining thing is 1 minus cos theta plus sin theta by 1 plus sin theta. This is what we are asked to find, and its value is also equal to x. Square root of 1 plus cos theta 1 minus cos theta. This is equal to cosecant theta plus cot theta. Second one, root of 1 minus cos theta by 1 plus cos theta is cosecant theta minus cot theta. The third one, root of sin theta by 1 minus sin theta is equal to secant theta plus tan theta. The fourth one, root of 1 minus sin theta by 1 plus sin theta is equal to secant theta minus tan theta. So all the problems are in the similar way. Even the solution is also similar for all. The answer is having square root. Answer is not having square root. Given problem is under root. So root must go away. And in all the numerators, if it is 1 plus, this is 1 minus. That means if the numerator is in the form a plus b, the denominator is a minus b. And if the numerator is a minus b, the denominator is a plus b. When the denominator is a minus b, let us multiply both the numerator and denominator by a plus b in all the problems. So the first problem, root of 1 plus cos theta by 1 minus cos theta this we will multiply by 1 plus cos theta into 1 minus cos theta into 1 plus cos, because the denominator is 1 minus cos, and here it is 1 minus cos theta into 1 plus cos theta. Now the numerator is 1 plus cos theta whole square under root. This is 1 plus cos theta whole square, and the denominator 1 minus cos into 1 plus cos is 1 minus cos square theta, and 1 minus cos square theta is sin square theta. Therefore 1 plus cos theta whole square by sin square theta. So this is 1 plus cos theta by sin theta. Now if we split this into 2, it is 1 by sin theta plus cos theta by sin theta. 1 by sin theta is nothing but cosecant theta, and the second one is cot theta. So the given problem is root of 1 plus cos minus cos. When the denominator is in a minus b, we are multiplying both numerator and denominator by a plus b. So this is 1 plus cos by 1 plus cos. So in the numerator 1 plus cos theta into 1 plus cos theta becomes 1 plus cos theta whole square. This is a minus b into a plus b is a square minus b square. Now 1 minus cos square theta is sin square theta. So if we take out the root, it is 1 plus cos theta by sin theta, and we have split it into two terms, 1 by sin plus cos by sin. This is 1 by sin is cosecant and this one is cot. Here actually when we get square root, we have to take plus or minus, but the quadrant is not given, therefore we have taken only the positive value. When nothing is given about no information is given about theta, we will take only the positive. Now the second problem is root of 1 minus cos theta by 1 plus cos theta. The denominator is 1 plus cos in the form a plus b. Therefore, this value under the square root, that is 1 minus cos by 1 plus cos theta, we are multiplying this by 1 minus cos theta by 1 minus cos theta. So in the numerator it is 1 minus cos theta whole square, and the denominator is 1 minus cos square theta. Thereby the numerator is, as it is 1 minus cos theta whole square, and the denominator is sin square theta. So when we take out the root, 1 minus cos theta by sin theta, now splitting this, 1 by cosecant theta minus cos by sin is cot theta. Therefore the answer is cosecant theta minus cot theta. So here it is a plus b, we have multiplied by a minus b in the numerator and denominator. This is 1 minus cos theta whole square, a plus b into a minus b, 1 minus cos square theta, and 1 minus cos square theta is sin square theta. Square root is applied, 1 minus cos by sin, therefore it is cosecant theta minus cot theta. The next one is 1 plus sin theta by 1 minus sin theta. So this is 1 plus sin theta by 1 minus sin theta is given. So the denominator is a minus b, therefore let us multiply both the numerator and the denominator by 1 plus sin theta. Now the numerator becomes 1 plus sin theta whole square, denominator is 1 minus sin theta. Now this is equal to root of 1 plus sin theta whole square by this is cos square theta. Now if we take out the square root, we are left with 1 plus sin theta by cos theta. When we split this, the first one becomes 1 by cos theta, means secant theta. The second one becomes sin theta by cos theta, means tan theta. The fourth one, it is root of 1 minus sin theta by 1 plus sin theta. So this is root of 1 minus sin theta by 1 plus sin theta. Let us multiply this both in the numerator and denominator by 1 minus sin theta. Now the numerator becomes 1 minus sin theta whole square, by 1 minus sine square theta. Therefore, this is root of 1 minus sine theta whole square by cos square theta. So, if we take out the root, it is 1 minus sine theta by cos theta, and by splitting this, 1 by cos becomes secant theta minus this is tan theta. Tan alpha minus tan square beta is equal to cos square beta minus cos square alpha, cos beta, cos square alpha. This is the problem. The left hand side is completely given in terms of tans, and the right hand side is given in terms of cosines. So first, this in three modals we can solve this problem. For the first one, taking the LHS and converting it into sine and cos, therefore the LHS is equal to sine square alpha by cos square alpha minus sine square beta by cos square beta. And the answer is given in terms of cosines. So, in the beginning itself I am changing these two. This is 1 minus cos square alpha by cos square alpha minus this is 1 minus cos square beta by cos square beta. Now, the LCM is cos square alpha into cos square beta. Now, these two are to be multiplied by cos square beta, and hence we'll get cos square beta minus cos square alpha cos square beta and minus cos square alpha plus cos square alpha cos square beta. Now this cos square alpha and cos square beta gets cancelled, and we are left with cos square beta minus cos square alpha by cos square alpha cos square beta. So this is the answer what we are asked to prove. So therefore, first we have expressed the left hand side in terms of sines. So this is sine square alpha by cos square alpha minus sine square beta by cos square beta. And before taking the LCM, since this is expressed in cosines, we have changed the sine square alpha as 1 minus cos square alpha, and this as 1 minus cos square beta. Now we have taken the LCM. Now, after taking the LCM, cos square beta multiplies these two. It is cos square beta minus cos square alpha cos square beta minus cos square alpha, and minus minus becomes plus cos square alpha cos square beta. These two gets cancelled. So we are left with cos square beta minus cos square alpha by cos square alpha cos square beta. Second method, let us take RHS and split this. Cos square beta by cos square beta cos square alpha minus cos square alpha by cos square beta cos square alpha. These two gets cancelled and these two gets cancelled. And this is 1 by cos square alpha minus 1 by cos square beta is left. This is secant square alpha minus this is secant square beta. But the answer is given in terms of tan. Therefore, let us write this as 1 plus tan square alpha minus of 1 plus tan square beta. So, this is 1 plus tan square alpha minus tan square beta. This two gets cancelled and we are left with the required answer, tan square alpha minus tan square beta. So we have taken the right hand side, split it into 2, and thereby 1 by cos square is written as secant square alpha, 1 by cos square beta is secant square beta, and this is converted in terms of tans because the answer on the left hand side is in terms of tan. So finally we could arrive at the answer tan square alpha minus tan square beta. The answer in the left hand side is in terms of tan square, and the answer on the right hand side is in terms of cos square. Tan square cannot be converted directly into cos, but tan square can be converted into the reciprocal of cos. So therefore, in the beginning itself, this tan square alpha can be written as secant square alpha minus 1. Since 1 plus tan square alpha is secant square alpha, this we know it. 1 plus tan square alpha is equal to secant square alpha. By using this, this is written as secant square alpha minus 1 minus of this, we will write it as secant square beta minus 1. When minus goes inside, we will be left with secant square alpha minus secant square beta, because this minus of minus plus 1 and minus 1 gets cancelled. Now let us write this as 1 by cos square alpha minus this is 1 by cos square beta. Now if we take the LCM, cos square beta minus cos square alpha by cos square alpha and cos square beta. Square root of secant square A plus cosecant square A is equal to tan A plus cot A. The first model, the answer is in terms of tan and cot. The left hand side, even though it is under the square root, it is secant square and cosecant square. Secant square can be converted into tan square, and cosecant square can be converted into cot square. Therefore, the LHS can be written as root of 1 plus tan square A plus 1 plus cot square A. And this will give tan square A plus 2 plus cot square A. This is tan square A plus 2. Even if it is multiplied by tan A into cot A, the value doesn't change because tan A into cot A is 1. Now this is A square plus 2AB plus B square. Therefore it is tan A plus cot A whole square, and hence becomes tan A plus cot A. So the left hand side is in terms of secant square and cosecant square. Secant square can be converted as 1 plus tan square A, and cosecant square A is 1 plus cot square A, since the answer on the right hand side is in terms of tan and cot. Now tan square A plus cot square A, and 1 plus 1 is 2. Even if we multiply this 2 by tan A into cot A, value doesn't change because tan into cot is 1. Now this is tan square A plus 2 tan A cot A plus cot square A square plus B square plus 2AB is nothing but A plus B whole square, means tan A plus cot A whole square. Hence, it is tan A plus cot A. The same problem in the second. This will write it as 1 by cos square A, plus this will write it as 1 by sin square A. We take the LCM, it is sin square A plus cos square A by cos square A. The numerator is sin square A plus cos square A is 1. The denominator, if square root is taken, it is cos A and sin A. And now this is to be converted in terms of tan. For that, we will write the numerator as sin square A plus cos square A by cos A and sin A. Now, if you split this into two terms, sin square A by cos A sin A plus cos square A by cos A sin A, square and cos cancel, square and sin cancel. The first is tan A plus cot A. So knowing different types of solutions for trigonometry is very important, and which will be useful in future also. That is why I am explaining you. This is written as 1 cos square A and 1 by sin square. After taking the LCM, numerator is sin square A plus cos square A. It becomes 1, and square root is taken, the remaining value is cos A sin A. When 1 by cos A sin A is here, the numerator is expressed as sin square A plus cos square A, and the denominator is cos A sin A. We have split into two terms, thereby we got the answer tan A plus cot A. Sin theta plus cos theta to cot theta plus tan theta is equal to secant theta plus cosecant theta. LHS, the first one is we are keeping as it is sin theta plus cos theta. The remaining part we will change it into sin and cos. So this is cos theta by sin theta plus this is sin theta by cos theta. Now we will take the LCM. This is sin theta plus cos theta. Here the LCM is taken. In the numerator we will be left with cos square theta plus sin square theta. In the denominator it is sin theta and cos theta. Now sin theta plus cos theta into cos square plus sin square is 1. Therefore, in the numerator we are with sin theta plus cos theta by this is sin theta cos theta, and if this is split into two terms, sin by these two becomes 1 by cos, means secant theta, plus these two cos gets cancelled and it is cosecant theta. Now cos A by 1 minus tan A plus sin A by 1 minus cot A is equal to sin A plus cos A. The left hand side is in terms of sin, cos, tan and cot, whereas the right hand side is in terms of sin and cos alone. So let us take the left hand side, convert it into completely sine and cosines. So therefore this is cos A by minus this is sin A by cos A plus this is sin A by 1 minus cos A by sin A. Here if we take the LCM as cos A in the denominator, when it goes to the numerator, numerator becomes cos square A by denominator becomes cos A minus sin A. And here also it is numerator becomes sin square A and denominator is sin A minus cos A. The main difference between the denominators of both these problems is this is cos A minus sin A and this is sin A minus cos A. In order to make the LCMs equal, we have to take minus common here. When minus is taken as common factor, this becomes cos A minus sin A and that minus and this plus becomes minus. Therefore, it is cos square A by cos A minus sin A minus sin square A by cos A minus sin A. The advantage is both the LCMs became same. Now, since the LCMs are same, if we take cos A minus sin A as LCM, in the numerator we will get cos square A minus sin square A. Now cos square A minus sin square A, the factors are cos A minus sin A into cos A plus sin A by this denominator is cos A minus sin A. These two gets cancelled and the remaining answer is cos A plus sin A. This is what we are asked to prove.